This implies ACM is 0.
Yes, sir. Yes, sir. VCM is constant.
Okay.
Yes, sir.
So if resultant external force suppose the resultant external force is 0,
Yes,
okay,
yes, sir. Then body
velocity or center of mass
will be constant. Either 0 or constant.
or this.
Follows, sir.
That means internal forces cannot change. Suppose, for example, sitting in the car, if you kick the car, will it go forward?
No.
No.
Not any force.
It cannot. Similarly, sitting on a chair, you cannot lift yourself. Remember, you press the ground. That is the action. Ground will give the reaction on your legs. That's the reason you are able to get up. Remember this?
Yes, sir.
So,
Yes.
internal forces cannot cause change in position. That is, position of center of mass or velocity of center of mass. Understood this?
Yes, sir.
So, this is nothing only law. F external is 0. Then what happens?
VCM, velocity center of mass will be constant.
So, mass of the system remains constant. No?
Yes, sir, constant.
That means linear momentum of system remains constant or not?
Yes, sir. Linear momentum system remains constant.
In the absence of external force, linear momentum remains constant. This is the only law of conservation of linear momentum, no?
Yes, sir.
Understood this?
Yes, sir.
Completed, sir.
Will you turn that?
Yes, sir.
1 minute, sir.
1 minute, sir. 1 minute.
Completed, sir.
Return this.
Yes, sir. Yes.
See, for example, a train is at rest in a station. Okay, does it mean none of the passengers are not walking inside the train?
No,
We
sir.
can see that passengers will be walking within the train. That means the components of the system may be walking. Why that person is walking? Because of friction between the foot and the railway platform, no? You're able to see the floor of the railway bogie. For example, this is a railway bogie or some lorry or something. It is at rest. Now you are walking. When you walk, what you will do?
friction, because of friction, we are
Push
working.
our legs
You will
backward.
apply a force. You rub your foot
Yes.
in the backward direction. Therefore, there will be friction on this. Therefore, you move forward and the bogie move. There is a force on this. Do you agree with this or not?
Yes,
But
sir.
remember that the center of mass remains there only. Understood this? Clear or not?
Yes, sir. Understood.
Understood or not?
Yes, sir.
Understood, sir.
This internal force, that's it, not moving.
So here remember that due to mutual internal forces. See here internal force on for this system. Friction is an internal force, no?
Yes, sir.
Yes.
Understood this?
Yes,
Clear?
sir. Clear, sir.
Should I turn there?
1 minute, sir.
Yes.
1 minute.
Completed?
Yes, sir.
Completed, sir.
Suppose this is mass 2m. This is another mass. Okay. There is only force is the force of attraction. This is 1, 2. Force on 1 due to 2. This is force on 2 due to 1. Okay. Now you can see what is F21?
Sir, force on
Force on 2
exerted
exerted by whom?
1.
Okay. These forces are suppose always internal forces will occur in pairs, no?
Yes, sir.
So agree till here.
Agree.
Agreed or not? Now you can see therefore what is the total force then? External force is 0.
0, sir.
And internal forces, see individually due to F1 to m, but
Will remain there itself. Will remain in the same position. Will not move.
or we can say this is agreed. That means if they are at rest, if it is at rest, it continues to be at rest, no?
Yes, sir. Yes, sir.
So therefore we can say that as external force is 0, so what you have, momentum of the system is constant.
Yes, sir.
Therefore you have initially the body is at rest, then finally you should have, suppose this is moving with 2m into V1 plus m into V2. Agreed?
Agree,
I'll
sir.
continue here. Initial momentum must be equal to final momentum. Initially, the bodies are at rest, for example. They must be having, understood this? This gives you that V1 must be equal to minus V2 by 2. That means the body should be moving in opposite directions, no?
Yes, sir.
Is it clear?
Clear, sir.
Completed?
Yes, sir. Yes.
See, suppose there's a bomb at rest. One second. Is it visible?
Yes, sir.
Yes, sir.
Visible, sir.
So just can you remove what the minutes? You need to copy. Before page I need to copy, sir. Can you remove this?
Pardon?
I did not copy, sir, that. Before this, what you have.
You did not copy here.
Yes, sir, somewhat left now.
No, fast. Headache with physics is that you teach theory and numerics.
That's it.
Interesting. But unless you do this, note this.
Yes, sir.
So turn this. Completed?
Yes, sir.
Hmm?
No, sir.
1 minute.
You're understanding what I explained that only.
Yes, sir.
Yes, sir.
కొంచెం అక్కడ ఒక్కరోజు కొంచెం 2-3 సార్లు వస్తాం బాగా చదివి. So return this.
1 minute, sir.
1 minute, sir. 1 minute. Sir, taken screenshots, sir. Completed.
Pardon?
Taken screenshots, sir.
Note on the notes.
Yes, sir.
The screenshot will not be there longer. Completed?
Yes, sir.
Yes, sir.
See, actually, when you're throwing an object, so for example, I'm throwing a conical object into air. Okay, so this may take any position.
Yes, sir.
It may move. You're throwing a conical object. Remember that the cone takes a complicated path. However, the center of mass will move in a parabolic path. Okay, this path is
Parabolic.
okay.
Yes, sir.
Yes, sir.
Understood this?
Yes, sir. Yes, sir.
Yes, sir.
Similarly, suppose you are throwing a bomb, it moves here. Somewhere explosion takes place.
Yes.
Once explosion takes place, what will happen? Different particles will may move in different directions.
Yes.
Yes, sir.
Okay, there is no guarantee that they should have. So now you can see the center of mass continues. Originally, this is the center of mass of the body here only, no?
Yes. Yes.
Yes, sir.
Yes, sir.
The center of mass continues to move in the same parabolic path.
For explosion.
Understood this?
Understood,
Yes,
sir.
sir.
All this we need. Tell.
Sir, even though the cone moves in different angles, the center of mass will only follow that parabolic.
Parabolic path, yes. Why?
Same
Because
goes for bomb also, sir.
because here we can see that. Please see what is the external force here.
Sir, for explosion, external force is zero. Only internal force are there.
Now here, please see. external force is not zero. That's where you have to use. Mg is still there, but delta t is zero, no?
Yes.
Delta t is time of explosion. Is very small, no? How much time it will take explosion?
Very very small.
So therefore, you can see that delta P, this is mg is acting, no doubt. But this is zero, no?
Yes, sir.
Yes, sir.
That means P remains Pf minus Pi is zero. What is the meaning of that? Pf equals Pa. That means center of mass continues to be in the same position, no?
Yes, sir.
Great.
And
Clear?
Yes, sir.
yes, sir.
Even after explosion, this takes place. Here, in this case, only mg acts, no?
Yes, sir.
Mg acts where? At
Yes,
center
sir.
of mass. Hence, from knowledge of projectile motion,
Sir, this side is not visible. Can you move face?
1 second.
Okay, sir. No visible, sir.
Understood this? In this case, explosion takes place, external force is there.
Yes.
Clear?
Clear, sir. Yes, sir.
Yes, sir.
Completed.
Completed this? Will you go ahead?
Yes, sir.
Yes, sir.
No visible, sir.
Yes, sir. Yes, sir.
So remember that always sum of internal forces.
Is zero.
Now, can internal forces change the kinetic energy?
Yes, sir. Because they can move.
No, sir.
See, suppose this is an object, this is another object, say Earth. Okay, now this is the gravitational force, no?
Yes,
This
sir.
is also a gravitational force, no? So definitely Ke changes, no?
Yes, sir. It's moving downward.
area of each particle
Changes. If they move.
Sir, but work done will be zero now, sir.
Who told you that?
Sir,
Did I say
internal
that?
forces
Here,
are-
no,
sir, internal
you are
forces-
concluding. Did I say that work done is zero of internal forces?
No, sir.
Then why you are concluding that? I told you internal forces cannot accelerate center of mass. I did not say that it cannot do any work. K of each particle of system changes due to, but hence total K of system will remain
Remain constant.
not constant. Will change due to what?
Due to internal forces.
In our body, we can see fluids, blood will be moving from one point to other now.
Yes, sir.
Agreed. So while that means are we able to, when you are sleeping, that process takes place now.
Yes,
Yes,
sir.
sir.
Internally they are moving, that means they are internal forces, no? But if are we moving, we are happily sleeping, no? So what is the meaning of that? Internal forces cannot change accelerate the center of mass. Okay?
Yes, sir.
Yes, sir.
But however, what is the net? We have to take net force now.
Net force. Internal force is zero. Is zero.
So what will happen? Center of mass
Center of mass is not accelerated.
Accelerated by internal force.
understood this? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Shall I turn this?
Yes, sir.
One minute.
Completed?
1 minute.
1 minute. Yes, sir. Completed.
Suppose it's a pen. Okay? If I apply a force here, you can see that it is rotating now.
Yes, sir. Rotating.
It is translating also, it is moving from one position to other now.
Yes, sir.
Translation means coordinates of center of mass must change. Now you can observe that the same thing is a pen. If this is the center of mass, you apply a force. The body will be moving to some other position. No?
Yes,
You
sir.
can see that center of mass moved now.
Yes, sir.
Move.
Coordinates.
Now the same force, if I apply here, then the center of mass moves, but the body also rotates. Did you ever observe?
Yes, sir. Sometimes.
Why? Because this torque is there now, this distance, R. You know this is R, this is F. So due to this there is a rotation, no? Remember R cross F.
R crossing. Torque.
If R is more, then torque is more, it will rotate more.
Yes, sir.
Okay, that means the same force, if it is applied here, is there R is 0, no? So what is the torque? 0. Therefore no rotation, no?
Yes, sir.
That means same force, but distance changes, rotation changes, no? So for studying rotation, two parameters are important. What is the force? Where it is applied. Agreed? For translation, where it is applied is not materialistic. It is applied or not. The statement says that whenever there is an external force, definitely the system must accelerate. This is the thing. Here there is no question of where the force is applied. That is the reason why we use concept of center of mass only for translation. Okay, translation means center of mass moves from one position to the other. For rotation we cannot, because definitely not only center of mass location, even R should be known where the force is applied. Understood this or not?
Yes, sir.
Yes, sir.
Clear? That is the reason why understand that action point. Understood this? Clear?
Yes, sir.
Yes, sir.
Translation means coordinates of center of mass will change. Okay?
Yes, sir.
Suppose now you are in your home, say take home as the origin, you have the coordinates as 0, 0. You go to college, your coordinates are changing, that means center of mass has changed. Understood this or not?
Yes, sir.
A fan is there, its center of mass remains there only, it is only rotating, no?
Yes, sir.
So for rotation, center of mass is immaterial. For translation, the center of mass is materialistic, most useful concept. Understood this?
Yes, sir.
Shall I turn?
External
Yes,
force
yes.
is, sir, the last line. Action point of external force is
Immaterial in producing acceleration of center of mass. Immaterial.
reduction.
So remember that.
Rotational motion.
Understood this? Clear?
Clear, sir.
Yes, sir.
Which motion?
Translational motion.
Understood this?
Understood, sir.
Yes, sir.
No.
Noted, sir.
So always remember that net external force is the mass of the system Understood this?
Yes, sir.
Will you go ahead?
Yes, sir.
Yes, sir.
Completed, sir. Completed, sir.
Okay, note on this. Visible?
Yes, sir.
Visible, sir.
కొంచెం కిందకు కొంచెం చూడాలన్నారు అది అలమర అనక నిన్న బాగా చెప్తే డోరు దిగపోతే కట్ చేసి హలో
Yes, sir.
కంప్లీటెడ్
No, sir.
కంప్లీటెడ్
1 minute, sir. 1 minute. Completed, sir.
See, once this is projected with speed, no? Where does it land when the center of mass goes and falls here on, no?
Yes.
Center of mass will not change.
Yes.
Okay, this distance is r, no?
R, sir.
R is how much?
U square sin 2 theta by. Yes, sir.
Because he gave 37 degrees now.
Yes, sir. Yes.
2 sin 37
3 by 5 and
cos 37 by 10. Find out this.
yes.
Completed.
Finished?
Yes, sir.
You'll get 960 here. Now
Yes,
let
sir.
us see what he says in the problem. One part which is smaller.
Yes, sir.
If it comes to rest, what is the only force here? Due to gravitational force, it falls here, no?
Yes, sir. False.
Agreed?
Yes, sir.
Clear? That means
Yes.
this coordinates of this is 960 by 2, no?
960 by 2 because highest one.
Center of mass may will always be in between the other two particles. Now, what is the other particle? That means this is 3m, no? Somewhere it should fall like this, no?
Yes, sir. It should fall.
Yes, sir.
1:3, no? Center of mass will be in between, no?
Yes, sir.
Now you can
Yes,
see XCM of the system will remain constant or not?
false. Because CN
This is X1, that is 960 by 2 plus, we don't know where it falls. Let us take it as some X. 3m into X by m plus 3m. What is the center of mass location? 960, no?
yes, sir.
So where does it fall here?
Sir, one minute.
Understood the method?
Yes, sir.
Understood, sir.
Completed?
One minute.
Completed?
Yes, sir. Complete. Doing so.
Shall I turn this?
Only.
Completed.
Right.
This is got X.
Pardon?
So got X is
1120, sir.
Okay.
1120 meter.
Now we can see that this another method we can do. This is center of mass, no?
This is center of
This is M, no?
Yes, sir.
This is how much you got? 960 by 2, no?
Right, 60 by 2.
You know that the other particle should be falling somewhere here, no?
Yes, sir, somewhere.
Yes.
See, yesterday we have seen that
Sigma MIRI.
is always 0. Remember, yesterday we have done this.
Yes, sir.
Look at that. There is mass into any mass into position vector of that. This is nothing but
460.
minus 480
480,
IK.
sir.
That is 3m into some R bar. R bar will be how much?
Alpha 1120, sir.
480,
No.
sir.
It will be 160. That means this is 160, no?
Yes, sir.
This 160 means this is 960. Already you have
Plus 160.
plus
960
160.
plus 160.
This way also you can do. Totally 1120, no?
Yes, sir.
Got it. Same answer.
That's why yesterday we like every theory point you should know, understand properly and try to recollect when needed. Yesterday I gave this in your notes if you want to check up. But when theory is going, you people will think there is no use, we'll do numericals. You cannot do a single problem without theory. That is only concept now.
Yes, sir.
Yes, sir.
1 the distance of 1120. Point of launching.
Understood till here?
Yes,
Yes,
sir.
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 We are taking the center of mass part as origin, sir. Point as.
Pardon?
We are taking the point of center of mass as origin.
Yes is what is R man? Look at yesterday. I'm saying yesterday's notes you see.
No, sir. Not that one, sir. We are taking
That one only here.
mass,
You're
sir.
not understanding what I'm talking. That only I'm taking here, no? Mass into position vector from where? Center of mass only, no?
Yes.
Again you're asking the same question. With respect to what? Center of mass. Okay? The sum of all this is
Is zero.
0. That means any particle multiplied by its position vector drawn from center of mass, sum up all those things, it will be 0.
Yes, sir.
Okay, suppose this is one particle by another particle here, this is the center of mass. This is M1.
M3.
This is R1 from center of mass only, no? Again you are saying we are taking yesterday's one,
R3
this is R3. So you have always M1 R1,
plus M2 R2 plus
M2
M3
R2 plus M3 R3.
equal to 0.
Always it will be 0. That is what I used to get.
Agreed, sir.
Yes, sir. Agreed.
Agreed.
1 minute. Sir.
See, there are two particles here. This is M1 moving with V1. Another particle is here. This is M2. This is 37 degrees here. The values given are N2 is 5 kg and V1 equals magnitude wise they have this. Okay, they collide at the origin. Understood this? See, the first one you can easily do. VCM we need.
M1 V1 M2 V2
M1 plus M2.
What is mass M1?
3
3. Velocity is, you can resolve this into vectors now.
yes
Okay.
sir
5 cos 37 minus I cap. 5 7 37 minus J cap. Okay.
Yes, sir.
Plus 5 what is the velocity as given?
I into 5J cap.
5 plus 3
You will get this. Understood this?
Yes, sir.
Understood the value of vectors?
Understood.
Yes.
When vectors or basic maths is being taught, we get irritated. Without vectors, you cannot. That's the problem we have in schooling. No physics, you cannot learn. The problem is that. Till here, you followed.
Yes.
Next, see, this is the first one. Is there any external force?
Yes, sir. Yes, sir.
Now you have, see, delta, just kinematic equation, nothing else. Delta of center of mass, ut plus half,
SCMT
this is final coordinate of center of mass, initial coordinate of center of mass. This is minus 1.5 plus 2j, time is 2 seconds. This is anyhow half 0 t square. Where do they collide? They collide at origin, no?
yes
Okay. This is minus 3i plus 4j. So final is asking that only, no? The
Yes, sir.
location of center of mass after 2 seconds. Position of center of mass. Okay, for this question. Understood this?
Yes, understood, sir.
Clear?
Yes, sir.
Okay, till here any doubts are there?
No, sir.
Yes, sir.
Yes.
Right, complete it and go to your class.
Yes, sir. Thank you.
Right. Right, okay.
Thank you, sir.
Okay, sir. Bye.
Thank you, sir. Bye, sir.
Thank you, sir. Bye.
Then apply అడిగేసారా
అది చేసినా చేసుకో దగ్గరికి అయితే అమ్మ 2 years అయిపోవచ్చు కొంచెం అంతే అయిపోవచ్చు